Hi guys, welcome to this video for question 3 of the 2019 level 3 integration paper. So the first question, find the integral of 24 times 2x minus 1 to the power of 3 dx. Right, so for this question, I would recommend that we do the substitution. So we say we'll let 2x minus 1 be equal to u. So now we'll have 24u3 dx. We need to find a way to get rid of the dx and replace it to du. So we'll be integrating with respect to du instead. To do that, we need to differentiate. So du over dx equals to 2. And therefore, du over 2 is equal to dx. So we can replace dx with du over 2. So we'll have the integral of 24u squared du over 2. And this will simplify to be 12u cubed with respect to du. So now we can integrate. So we add 1 to the power. So 3 plus 1 is 4. Divided by the new power. 12 divided by 4 is 3. So that becomes 3u to the power 4 plus c. And now we can substitute u back as 2x minus 1. So we will get 3 times of 2x minus 1 to the power of 4 plus c. And that would be our answer to this question. And that would be an achieved question here. Alright, question B. Solve the differential equation dy over dx equal to 4 sec squared 2x, given that when x equals to pi over 8, y equals to 5. Alright, so we need to, in order to solve this differential equation, we need to integrate. So to integrate, we know that sec squared x goes back to tan x. And we need to divide by the derivative of the inner function, because usually when we differentiate, we multiply by the derivative of the inner function. So when we go back, we have to integrate, we will divide by the differentiation of the inner function. So y would be equal to 4 divided by differentiation of 2x is just 2. So 4 divided by 2 tan 2x. And don't forget the plus c. So we know that when x equals to pi over 8, y equals to 5. So 5 equals to 2 tan of 2 times of pi over 8, that's pi over 4, plus c. So tan pi over 4 equals to 1. So that becomes 5 equals to 2 plus c, and therefore c equals to 3. So therefore our equation will be y equals to 2 tan 2x plus, c plus 3. And that should be our final answer to this question. This is an achieved level question. Alright, question C. Find the indefinite integral between x equals to 4 and x equals to 1 of x plus 1 plus of x divided by x plus 1 dx. So there's many ways that you can do this question. You can use substitution. You can substitute x plus 1 as u. But for this question, I decided to use a long division to simplify this fraction into 2 separate components. So we do a quick division here. So we do x divided by x plus 1. We'll put a 1, so x plus 1, negative 1. So now we can split this fraction up into 1 plus of negative 1 over x plus 1. So we can now say that the integral would be x plus 1 plus this 1 here, so plus 1 minus negative 1 over the divisor. So minus 1 over x plus 1 dx. So now we can integrate, so we can say x squared over 2. 1 plus 1 is 2. If we integrate that, it becomes 2x. So 1 over x plus 1, negative 1 over x plus 1. If we integrate that, we'll get negative ln of x plus 1 between 4 and 1. Right, so x squared, 4 squared is 16. 16 divided by 2 is 8. So 8 plus 2 times 4, which is 8, minus ln of 4 plus 1, which is ln of 5, minus 1 squared is 1 over 2, plus 2 times 1, which is 2, minus ln of 1 plus 1, which is 2. Right, if we simplify this, we should get 16 minus ln of 5. Sorry, so 16 minus should get that our answer equals to 12.584. That should be our final answer for this question. So to get this final answer here, you should get a merit grade. To get an achieved grade, if you can have a correct integration, you will get an achieved. So correct integration, so that will be this step here, that will get you an achieved. All right, question D. If dy over dx equals to 4x over 4x squared minus 3 plus root of x and y of 1 equals to 2, find y of 4. Okay, for this question, if you notice the denominator here, if we differentiate the denominators, if we say f of x equals to 4x squared plus, minus 3, if we do find the derivative of that, it will give us f of x equals to 8x. So notice that 8x is exactly 2 times as big as 4x. So you know when we have an ln function, let's say we have ln of, we'll say 2x plus 3. When you differentiate ln, so let's say y equals to ln, so dy over dx will be equal to the derivative of ln of 2x plus 3, which is 1 over 2x plus 3, multiplied by the derivative of the inner function, which is 2x plus 3. The derivative of 2x plus 3 is just 2, so we will multiply it by 2. So in this case, we'll have some x, some unknown, we won't call it x, that makes it confusing. We'll have some a, so in this case, in this numerator part, we'll have this a, we don't know, multiplied by 8x, which is going to give us our numerator, which is 4x. So notice that if we rearrange, we should find that a equals to 1/2, which would be in front of the ln function. So now that we've got that out of the way, we can integrate this function. So we can say that y, we rearrange this square root of x. Square root of x is x to the power 1/2. Okay, so we have dy over dx equals to 4x divided by 4x squared minus 3 plus x to the power of 1/2. So therefore y would be equal to 1/2 of ln of 4x squared minus 3 plus x to the power, x to the power of 3 over 2 divided by the power, which is 2 over 3, plus of c we do not know. Alright, so we know that when we substitute x equals to 1, we get y equals to 2. So we'll use that to find our c value. So 2 equals to 1/2 of ln of 4x squared minus 3, that's ln of 1, plus 2 over 3, 1 to the power of 3 over 2, plus c. Alright, so we should, ln of 1 is 0, so that's good. So 1 to the power of 3 over 2 times 2 over 3. So we should get that our c value is 4 over 3. So c equals to 4 over 3. So now we want to find y of 4. So y of 4, that equals to 1/2 of ln of 4 squared is 16. 16 times 4 is 64, so ln of 61. Plus 2 over 3, 4 to the power, not 4 times, 4 to the power of 3 over 2 plus 4 over 3. Alright, so ln of 61 plus, 3. Should get that our answer is equal to, so y should be coming out to be 8.722. That should be our final answer for this question, and that will get us a merit grade, with an achieved grade being a correct integration. So correct integration would be up to this step here, will get you an achieved. Alright, question E. An inverted right pyramid has a square base and a height of 1.5 meters. The pyramid is initially filled with water to a depth of 1 meter as shown. So we have our diagram here. So the energy required to pump out water out of a tank of height h is given by 9,800 multiplied by the definite integral of x equals to h and x equals to h minus d. Okay. So it tells us that E is the energy in joules, D is the initial depth of the water in the tank, H is the depth of the water in the tank at any instant, and A of H is the area of the surface of the water at this instant. So find the energy required to pump out the water out of the tank as shown. Alright, so in this case here, we have a pyramid initially filled with water to a depth of 1 meter. So the initial depth is 1 meter, so we already know that our D equals to 1 meter. we know that our big H here must be equal to the height of the pyramid. So our big H here is equal to 1.5 meters. Alright, so H we do not know. So H is the depth of water at any instant. We do not know that. And A of H is the area of the surface water at this instant. So the area of the surface of the water is actually this square here. So we need to find out the length of this square here. So we know that this is the same pyramid. So the pyramid on the right A and the pyramid on the pyramid on the left A and the pyramid on the right B is going to be the same pyramid. So they're going to follow the same ratios. So the ratio of this length and this height is 0.9 over 1.5. So that's our length over height. So for this pyramid B, it's going to follow the exact same ratio, and that's because it's the same pyramid. So we'll know we don't actually know this this length. We don't know, so we'll call it A for now. Sorry, it's frozen. Okay, so we'll call this length A for now. So we'll say that A over our H must be equal to 0.9 over 1.5. Because H we do not know right now, okay? So 0.9 divided by 1.5, 0.9 that's 0.6. So A over H equals to 0.6, and therefore A equals to 0.6 H. So now we can have a formula for our surface area. So our surface area equals to A squared, which is equal to 0.36 H squared. Alright, so now I believe we can start plugging in our numbers. So E equals to 9,800, and our big H is 1.5. H minus D, so 1.5 minus 1, that's 0.5. Oh, sorry. That is 0.5. Bracket 1.5 minus H, we do not know, and times of A of H, which we have established is 0.36 H squared with respect to DH. Okay. Alright, so now we can expand our brackets. So 9,800, 1.5, 0.5. So 1.5 times 0.6, 0.36, right? So it becomes 0.54 H squared minus 0.36 H cubed DH. Right, so now we just need to apply simple power rule here. So we add 1 to the power and we divide by the new power. So 9,800, 1.5, 0.5. So 0.54 divided by 3, that's 0.18 H cubed minus 0.36 divided by 4, that's 0.09 H to the power 4. Sorry, we don't need this integral sign anymore. And that is between 1.5 and 0.5. Right, so we substitute our numbers in. So E equals to 9,800, that's on the outside, multiplied by 0.18, 1.5 cubed, minus 0.09, 1.5 to the power 4, minus 0.18 times 0.5 to the power 3 minus 0.09 times 0.5 to the power 4. Alright, so just plugging these numbers into your calculator. So times... Alright, so we should get 9,000, so we should... Oh, why is it frozen? Alright, so 9,800... my thing is playing up, isn't it? Sorry, guys. Apologize. Okay, so 9,800... Oh. Come on. Don't have time for this, come on. 0 point... Oh. 0 point, oh gosh, Mike. Sorry guys, I apologize. My pen is acting up for some reason. Let me try to fix this. Alright, so we have 0.135 in the brackets, and that's equal to our energy. So 9,800 times 0.135, that is equal to 1,323. Energy is measured in joules, but I don't think you need the unit. Unit is not important here, so... To get a correct answer, that's 1,323. That's an excellence grade. To get a merit grade, you need a correct integration. So correct integration gets you a merit. I believe that will be this step here. That will get you a merit grade. and there's actually no specification for achieved. So I believe that for this specific question that you cannot get an achieved, because there is no specification or marking schedule for an achieved grade. So I believe that the lowest grade you can get for this question is a merit grade. I believe that's it. So thank you for watching this video. I hope you enjoyed the video, and if you liked the video, please drop a like below and please subscribe to my channel, and I hope to see you all in the next one. Thank you. Bye.